Welcome to Brain Vision.
Hi everyone. In this problem is based on the concept of equilibrium of forces. For equilibrium of forces, net force acting on the given system or a body must be zero. So this concept we will apply for system to be in equilibrium. Now let me explain the problem given. In this problem we have to calculate the largest mass of the pipe which can be suspended from H point. The mass of the cylinder we have to calculate what its value should be largest. If maximum tension in each cord, if maximum tension in each cord to be 500 Newton. Let us start solving it. Tension in HA cord, THA, this is TAE, this is TAB, TBC and TBD. There is a very, I am writing here because there is a, I am getting less space there. So I am writing here TBD. This is your y-axis. This is x-axis. At this point again, this is y-axis and this is x-axis. So we should apply the concept of equilibrium at every point. As you know, summation of all forces must be zero. That is for equilibrium. This is the condition for equilibrium. That is summation of fx and summation of fy must be zero. So we have to apply for different points. If we see at point H, its a weight W is equal to mg will act vertically downward. We can say only W. W is equal to mg. This is the weight of the body. I am saying equation 1. Now apply equilibrium force at H point. So at H point, summation of Fy must be zero. That is tension in HA cord must be equal to weight. So this is one answer we will get. Now we will apply the condition of equilibrium at point A. Summation of Fy must be zero. Let us see the figure. So tension in the AB string has to be resolved into Y component and X component. So it will be TAB sine of 60 minus this is tension in HA vertically downward. No other force is acting at A in Y direction, so that must be zero. So from here, tension in AB you will get root 3 by 2 minus W is equal to 0. So you may write tension in the cord AB must be W into 2 upon root 3. On solving, this value will be 1.1547 into weight of the cylinder. So this is your third equation. Now apply summation of all forces at a point along x-axis must be 0. So resolve these forces along x-axis to be 0. So this will be TAV cos of 60 along negative x-axis, and this is along positive x-axis. No other force will be along x-axis. So here we may write TAE minus TAV cos of 60 must be 0. So here we will get the tension in the AE chord. It will be TAB already we have calculated 1.547 into weight of the cylinder cos 60 is half. So on solving, tension in the chord AU will get 0.577 into weight of the cylinder. Say this equation to be 4. Now summation of all forces along y-axis must be 0 at point A. That already we have done. Extremely sorry. Now we have to at B point. Summation of all forces at P point must be 0. So summation of Fy must be 0. Let us see here what forces are acting at B. Tension in BC, tension in BD, and tension in BA or AB you may call. So resolve this force along y-axis and this force along y-axis, and that must be 0. So we are going to resolve. Now see here, tension in BD into 3/5 minus tension in AB sine of 60, that must be 0. So tension in BD you will get 5/3. Tension and AB already we have calculated 1.547. Weight of the cylinder into sine of 60, that is √3/2. So on solving, tension in the BD we will get 1.667. So this is equation 5 I am saying. Now summation of all forces along x-axis at point B must be 0. So see the figure again. You have to refer the figure. This is along x-axis. You have to resolve this force along x-axis as well as this force along x-axis. So from the figure we can write summation of all forces along x-axis at B point. We can write minus BC, it is negative x-axis, plus tension in BD along x-axis, tension of AB along x-axis, that must be 0. So tension in BC we will get, that I have written here wrong, this is BD actually. So I am correcting this BD. So you will get tension in BD 1667, weight of the cylinder 4/5, plus tension in AB, you may see tension in AB is 1.1547 weight into half. On solving, you will get this value to be 1.9707. So if we compare equation 2, 3, 4, 5 and 6, we will find the maximum tension is on the chord BC. So BC chord having maximum tension and it should not exceed by 500 Newton. So from here we will substitute using equation 6, 500, 1.9707 mass of the cylinder into G, that is 9.81. So from here mass of the cylinder we will get 26.7 kg. So maximum mass the cylinder which can be suspended is 26.7. That is the answer for this problem. Thanks for watching it.